Welcome guys. In this video, I will be solving this particular question from the chapter Kinematics. Okay, the question says a small box of mass m equal to 0.1 kg is kept on a top of a frictionless ramp with a spring at h2 equal to 0.5 meter from the horizontal table. Okay, they have given that h2 equal to 0.5 and it is on the top of this table where h1 equal to 4 meter. So the total height will be 4.5 meter. Okay, now the ramp is angled at theta equal to 30 degree. This angle they have given at 30 degree. Okay, the spring is pushed down by delta x equal to 0. Now this is the distance where the spring could be compressed. Okay, and to its rest of length, the box leaves the ramp at speed v meter and lands at a distance delta d away from the table. Given spring constant k equal to 6 Newton per meter and acceleration due to gravity is 10 meter per second square. Okay, friction is negligible in this case. Okay, let's analyze the problem and break it into pieces so that you could understand it easily. Here there is a spring. Now this could be compressed so that the length becomes delta x. Now if this is delta x, then what will be the length of this one? So let's say sine 30 degree is equal to, the definition is opposite side by adjacent side. So let's take this as x. So x by x. Now sine 30 degree 1 by 2, that equal to x by delta x. Now x equal to delta x by 2. So therefore it will be x equal to delta x by 2. Okay, now let's solve for this. For solving the first question and to get the value of v, we need the help of law of conservation of energy. Let's analyze the situation first. Okay, now since the spring is compressed, the energy of this block could be stored in the form of spring potential energy. Okay, so what is the spring potential energy formula? Half into k into delta x distance square. Okay, so it's compressed, so the energy is stored in the form of spring potential energy. When this spring is released, then the block would come here and it will fall to the ground. Okay, now at here, due to this height, it will have an potential energy, and after this block leaves this ramp, it will have a kinetic energy of mv square. So let's equate it before releasing and after releasing the block. Okay, now half into k into delta x whole square equal to, after releasing of that spring, the block reaches the height of the ramp and it will be mg into, what is the height? What is the height here? It's delta x by 2. Now delta x by 2 plus half m v square. Block leaves the ramp, it gets kinetic energy because it falls to the ground. Okay, now half m v square is equal to mg delta x by 2 minus plus half k into delta x square. So v is equal to k by m into delta x whole square minus g into delta x whole to the power 1 by 2, because v square now it's under root. Okay, now v is equal to, let's substitute 6 divided by mass is given as 0.1, delta x is 0.3 the whole square minus 10 into 0.3 whole to the power 1 by 2. As such, you plug it in the calculator, you will be getting 1.55 meter per second. So we have got v as 1.55 meter per second. Now they are asking this particular distance. Okay, so to find this particular distance, we need to find the time. We have got velocity, we have found just velocity now, so that equal to 1.55 meter per second. Okay, we have got velocity here, but we need time to calculate this distance, this particular distance. Since this is an horizontal distance, we need to calculate the time of flight. Okay, to calculate the time of flight, we have a formula in kinematics that h is equal to ut minus half of dt square. Since the block leaves the ramp, it has an velocity v. Okay, so since this is the velocity component, let's split this. This is v sine 30 degree and this is v cos 30 degree. Okay, to find this distance we need this velocity, but to find the time of flight we need this vertical component of velocity, because the velocity vector is pointing this way. Okay, now the gravity is acting down, so the time period depends on both this v sine 30 degree, which is the vertical component, and the value of the gravity. Okay, let's substitute in the particular equation. Now height of the tower or height is minus 4.5, because 4 plus 0.5 is 4.5, equal to v into sine 30 degree into t minus half into 10 into t square. After solving this, we will be getting t is equal to 1.0293. Okay, now I have already said that the velocity is in this direction. Then let's split the components. Okay, this is v sine 30 degree, this is v cos 30 degree. With the help of this component we have found the time period, but we need to find this particular distance. Since this is an horizontal distance, now v is equal to d by t. D is equal to v into t, and this particular distance traveled by the block is due to this component of the velocity vector. So therefore d is equal to v into cos of 30 degree into t. Okay, now d is equal to v 1.55 into cos 30 degree value root 3 by 2 into time of flight 1.0293, and the final answer is 1.38 meters. If my calculations all are correct and if I have not committed any single error in any of the step, then the answer will be 1.55, and for this one 1.38. Thank you.